Hello everyone, myself Juli Yadav and I'm the assistant professor at Ajay Kumar Garg Engineering College, Ghaziabad. So today's topic of presentation is LALR Parser. What is LALR Parser? LALR Parser is a parser that we used to call it as Look Ahead LR Parser. It is basically the intermediate in power between SLR and CLR parser. Means its power lies between SLR and CLR parser. So we can say that CLR parser is the most powerful parser. It is slightly lesser than the CLR parser. It is the compassion of CLR parser. Hence, table obtained in this will be smaller than CLR parsing table. So the CLR parser is the most powerful parser. We have to get the LALR parser from the CLR parsing table itself. So before constructing the LALR parser, we have to construct the CLR parser. Here, first of all, we will construct LR1 canonical items. Next, we will look for the item having the same first component and they are merged to form a single set of items. So what we have to do? We have to construct the LR1 item table, then LR1 items, then we have to look for the items that have the same first components, means the production or the components that have the productions that have the same components. Then we merge to form a single set of items. Suppose there is an item I3 and I6. If they both have the same first component, then we have to merge those states or those items to form a new state. It means that the state have the same first component, but the different second components can be integrated into a single state or item. So the general syntax become A gives alpha dot beta comma A. This is the general syntax of the production. Here A gives alpha dot B is the production and A is the terminal or right hand marker dollar. Means this is the production. This can be in any form, like the production is in the form of A gives alpha beta. Here the dot is what? Dot is the is used to find the look ahead. So here is the dot. Now what this A is here? This is the look ahead of this particular production. So the LR1 items, how we will find the LR1 items? We can find the LR1 items by finding the LR0 items plus their look ahead. It is different from LR0 items only in the case of look ahead. Means in LR0 item we need not to find the look ahead, but while we are constructing the table for LALR or CLR parser, we need the look ahead. We have to find the look aheads of that particular production. So how does the LALR parser basically works? So the working of LALR parser is shown by the given flow chart. Here we can see the input is what? The context free grammar. Or grammar can be in the form of the what does the grammar is? Grammar is basically the set of rules. So the production, we can say that the context free grammar is contains the production rules. So production rules are the input for the LR items. Then we have to construct a set of LR1 items with their look ahead. Now for constructing the LR1 items with look ahead, we need to follow these 3 steps. The first step is we have to construct a augmented grammar. Augmented grammar is what? When we place the dot, like if there is a production A gives B, right? If we place dot in front of B, then we can say that this is the augmented grammar. Now next step is we have to find the closure. We have to find the closure of all the productions. Then we find the go to. Now the second state is when we find the when we constructed the LR1 items with look ahead, then what we have to do, we have to merge the items or state with same first component but different look ahead. We have to merge those states or those items that have the same first component but their look ahead is different, then we can merge those items or states. Now, after finding the merged states or items, then we can construct a parsing table. After parsing table, we can now pass the input string that can be of any value, or any number of items can be there in that particular string. String is what? It contains the set of terminals, like if A, B, C, D. Then if this is a string, then we have to pass this string using the LALR parser. So, while we are passing this input string, then we have two options. First one is either the string is accepted or it is rejected. This is the working of the LALR parser. Now, how we can find the, here we, I have just told you that LR1 can be constructed by using LR0 items with their look ahead, right? Then how we can, this we have already done, how to find the LR0 item. Now our focus is on how we can find the look ahead. So to find the look ahead, we have three cases. The first case, if we have the production like A gives alpha dot BC comma A, means if we have this kind of production, then suppose this is the 0th production. Let's suppose if this production is the 0th production. Now since dot precedes B, here we can see dot is before B. So what we have to do, we have to include all the B's productions. Suppose if there is another production B gives D, then what we have to do, if the dot is before B, then we have to check all the productions of the B and we have to include those productions in that group. Now the first production is B gives dot D. What does it means? If dot B, if the dot precedes B, then we have to include the B's production also. So here we have included the B production with dot that precedes D. Suppose this is B's production. This one is B's production. The look ahead of this production is given as we look at previous production, that is 0th production. How we find the look ahead of this particular production? Then we have to look ahead the the previous production, that is the 0th production. Whatever is after B, what is after B? After B is C. We find first of that value. Then what we have to do? We have to check the previous production, that is A gives alpha dot B, C. Then we have to check what is after B. After B is C, then we have to find the first of C. That is the look ahead of first production. Then we have to find the first of C. Then the value that we get from first of C is the look ahead of this particular production. So in this way we have find the look ahead of first production also. Here let's assume the first of D is first of C is D, then production would become B gives dot D comma D. Why D? Because this is the first of C, which is after the B. So this is the case 1. Now case 2 is, now if the production is like this, A gives alpha dot B comma A. If this is the case, then we have to find, how can we find the look ahead of the next production? Here we can see there is nothing after B. Here we can see in the earlier production what was there? After B there is a terminal, non-terminal C, but here is no non-terminal. So how we can find? So the look ahead of the 0th production will be the look ahead of the first production. If these two are the, if this is the 0 and this is the first production, then the look ahead of zeroth production is the look ahead of first production. If A is the look ahead, then here A is the look ahead of the first production itself. Let's now the case 3 is assume a production A gives A comma B. If the production is if the production contains A slash B, this type production is there where there is no non-terminal, all the values are the terminal symbols, then how we can find the look ahead? Then let's assume A gives A comma dollar, which is the zeroth production. A gives B comma dollar, which is the first production. So here the first production is a part of the previous production. This is the first production which is the part of the previous production, right? So the look ahead will be the same, that of the, here the look ahead is dollar. So the look ahead of the first production is same as the look ahead of the previous, that is the zeroth production. Why? Because they both are the same. As we can see here, they both comes in the same rule. So in this way we have found the we have found the look aheads, how we will find the look aheads of any production. Now here are the steps how we can construct an LALR parsing table. So to construct LALR parsing table, we have to follow the following steps. The first step is we have to write the augmented grammar. I have just told you what is augmented grammar. If there is a production, let's suppose if there are production S gives AB, A gives BC, B gives C, A, and C gives D. If this kind of productions are given, then how we can write the augmented grammar? We can place, if this is the zeroth production, then S gives A, B. What we have to do to get the augmented grammar? We have to place a dot in front of the production. If S gives, if there is a production S gives AB, then we have to write a dot that precedes A. So this is the augmented grammar. Now how we can find the other rules? Now we can see here S gives dot A, B. Here after dot what is there? There is a non-terminal. So what we have to do? We have to check all the productions that are generated from A. Suppose if there is a production this and another production B, then what we have to do? We have to include all those productions also. Like if there is a production, now we have to check the production of A, that is A gives BC slash B, then A gives dot BC slash dot B. So what we have done? We have placed the dot in that precedes BC and small b. Now here we can see the dot precedes B, then what we have to do? If after dot there is a non-terminal, then we have to include the production of that non-terminal also. Now the production of B is what? B gives dot C, B gives CA, then we have to write the production of B gives dot CA. Now we can see here the dot product is before, or it precedes the C. So what we have to do? We have to write all the productions of C also. The production is C gives dot D. So this is what? This is the augmented grammar. Hope you all have understood. Now This was the first step to find or to construct the LALR parsing table. Now the second step is we have to find the collection LR1 collection of items to be found. So how we can find the LR1 collection of items? If I have just told you S gives dot AB, A gives dot BC slash dot B, then we have to find all the collection of items that can be generated from these particulars or the set of production rules. Now, after finding all the LR1 collection of items, then we have to define two functions, that is goto. Goto is what? That contains or that consists of all the list of terminals. Means in goto, we basically we have to construct a parsing table that has the set of list of terminal symbols, and goto is performed on the terminal symbols and action is performed on the non-terminal symbols. So goto contains all the non-terminal symbols that are present in the particular grammar, and action is performed on all the set of non-terminals that are present in the particular or the set of grammars. So after finding the gotos and actions, then we can construct a LALR parsing table. Now let's see an example how we can construct an LALR parser. So how we can parse a particular string, or how we can construct a parsing table for LALR parser. So I have just told in my previous thing that the CLR parser is more powerful than LALR parser, and we can get the LALR parser only when we have constructed the CLR parsing table. So before constructing the LALR parsing table, we need to construct the CLR parsing table. So here is a grammar like S gives A, and A gives A slash B. So this is the grammar that we have given. Now we have to find the augmented grammar for this particular grammar. How we find? That is the first step of constructing the LALR parser, or we can say the CLR parser. So the first step is we have to find the augmented grammar. I have just told you how we find the augmented grammar by placing the dot in front of the start symbol. If this is the start symbol S, then we have to check the production rules. We have to add another we have to add a production, that is S dash gives S. Right, here we can see we have already added another production, that is S dash gives dot S. Now what we have to do? Dot precedes what? Dot precedes S. Then what we have to do? We have to include all the productions that contains S. So what are those productions? Those productions are S gives A. So what we have to do? We have to include all the productions that we get from the S. So S dash gives dot S. Then the productions of start symbol is S gives dot A and A. Right, here we have right dot. Now after this we can see A precedes dot precedes A. Then what we have to do? We have to include the productions of A also. Then A gives dot A. And there is another production, that is A gives B, then A gives dot B. So this is the augmented grammar for this particular grammar. Right, the first step we have already computed. Now we have to find the LR1 collection of items. How we can find the LR1 collection of items? So let's first we have done the augmented grammar. We have got the augmented grammar. Now what we have to do, we have to find the look ahead of all the productions. So how we can find the first rule is look ahead is the initial look ahead is always the first production is what? S dash gives dot S. So the first production look ahead is always what? It is the dollar. So look ahead of first production is dollar. So now the first production came into existence because of dot proceeds before S. Dot proceeds before S. So another production S gives dot A come into existence. Right. So how we can find the look ahead? There is nothing after S. Here we can say there is nothing after S. So look ahead of zero production will be the look ahead of first production. If there is a production or there is a terminal or non-terminal symbol after S, then we have to use those rules or those cases that I have just explained. Now the case I think 2 or 3 explains if there is no terminal or non-terminal after S, then what? How we can find the look ahead of first production? Then the look ahead of first production is same as the look ahead of the zeroth production. So the look ahead of first production is dollar itself. Now the second production came into existence, that is this one is the zeroth production, this one is first production. Now second production is A gives A, then how we can find the look ahead for this particular production? Here now the second production came into existence before of dot before A in the first production. After A there is A, so first of A is A comma A. After A, after this A there is A which is a non-terminal. Then what we have to do, using case 1 we can we have to find the first of A, means first of this A, and the first of A is A is what? A comma B. So first of A is A comma B. Then look ahead of this production is what? A slash B. And the third production is what? A gives dot B. Right? Then how we can find the look ahead? As this production is the part of the second production, so the look ahead of second production is the look ahead of third production. This is the second production and this is the third production. So the look ahead is also the same. Dot B comma A slash B. So here we can see the rules of finding the look ahead of the productions. Now the second step is finding the LR0 collection of items. So this diagram shows the LR0 collection of items. Let us understand it one by one. So this is our augmented grammar that has augmented grammar with look aheads. So what we have to do? We have to find the canonical, or we can say the collection of items. So how we can find? If the let's see the first production, that is S dash gives dot S. So there can be a move for S. Why there is a move? Because dot precedes S. Then for S, if we move dot beyond S, then the production will become S dash gives S dot. So what does it mean? Here are some rules that need to be followed to find the collection of items. The rules are like, if any non-terminal has dot preceding it, we have to write all its production and add dot precede each of its production. Means if there is any production like S gives, S dash gives dot S, then what we have to do according to rule 1, we have to write all the productions of S with dot in front of those productions. From each state of the next state, the dot shift to one place to the right. For each production or for each state, or to the next state, the dot moves to the right. In the figure, I0 consists of augmented grammar. This is what? This is the augmented grammar. Then I0 goes to I1 when dot of zeroth production is shifted towards the right of S dash gives S dot. So, I0 goes to I1 when dot product is shifted towards the right of S. So, now the production will become S dash gives S dot and it's dollar. This state is accepted state. Why this is accepted state? Because S seen by the compiler, right? Since I1 is a part of zeroth production, the look ahead is same as that is the dollar. Here you can say I0 goes to I1, so the production will become like this, and dollar is same as the look ahead of the I0th production. So, this state, we can say this state is what? This state is the accept state, right? Now, the second production is S gives dot A comma dollar. So, I0 goes to I2. How it goes? When dot of first production is shifted towards right, the production is S gives dot A. When we shift this dot beyond or right of A, then the production will become like this. Now we can say A is seen by the compiler, means the when the dot products came to the right of any non-terminal symbol, we can assume that terminal or that symbol is seen by the compiler. Since I2 is a part of the first production, so look ahead is same as that of the first production, that is dollar. You can see here for A, we have moved here, and why we have included this? This we have included because this non-terminal A is having the its dot is precedes this A non-terminal. So, we have included all those productions of the A, right. Now, I0 goes to I3 when dot of second production is shifted towards the right. This is the first zeroth production, first and second production. Now, we have to move this dot product beyond or the right of small a. Then, when we have moved this, then A gives A dot A, and the look ahead is same as that of in the previous production. So, look ahead is same, that is A slash B. Then we can see here dot A. Dot A is what? Means A is the non-terminal and dot precedes that non-terminal. So, what we have to do? We have to write all the productions of A, but here look ahead is what? Look ahead is same as that of this production, that is A slash B. So, we have included all the productions of A. We have two productions that we have included. And now, the third production is what? A gives dot B, that has the look ahead A comma A slash B. So, we have to move dot to the right of B. Then to the right of B we have moved, then we get I4, means I0 goes to I4 by moving a B that we have placed here. So, the look ahead is same as in the previous state. So, we have I2, I3, I4. Why we are not considering I1? Because there is nothing, means we can say the dot is at the end of the production. If the dot comes to the end of the production, then there is no need to write the production rules, or we can say that production is acceptable, or or we can say the production is reduced. Why we are using here except? Because here S is what? S is the start symbol, that's why it is the except state. Now, there is a go to from I2 to I5 because this A has to be moved to the right of A. So, this is the production. Now, we have to check A as gives AA. S gives AA. So we can say this is what? This is the reduced state. This is the reduced state, and this is reduced by, let's assume this is 1, this one is 2, and this one is 3. So this is reduced by, so we can say this is reduced 1. Why we have to say why we are saying this is reduced 1? Because this is reduced, or the dot comes at the end of the production due to this grammar or this production rule. Now this has completed. We have to shift A to the right of small a, then the production will become A gives A dot A comma dollar. Why dollar here? Because here dollar is the look ahead of this production. So here we can see dot A. So we have to include all the productions of A. Here we have included, right? Now this has been done. Now there is a go to from I5 to I7. Why? Because there is a shift of dot from over B. So over B we have reached from item I2 to I7, that is A gives B dot. Here this is also the reduced state. So reduced state is this one is reduced state. So reduced state is what? Reduced by 3. So this one is reduced 3. So in the same way we can construct the items, or we can construct the LR0 collection of items up to I9. So this is the reduced state, this one is the reduced state, this one is the reduced state, right? We have number of reduced states. So this is all about that I have just explained. You can go through from all the points. Now the table is like, I have just told you there are two functions, action and go to. Action contains all the set of non-terminals, sorry, all the set of terminal symbols, and go to contains all the set of non-terminal symbols. So in the grammar we have only two non-terminal symbols, that is A and S, and in the grammar we have three. We have two non-terminals, but dollar is also a non-terminal. We have added it in our augmented grammar. So dollar is also the set of non-terminal. So here A, B and dollar are the actions that has to be performed. So on item 0, by taking small a, we are reaching to I3. I0 on small a, we are reaching to I3, right? On B, we are reaching to I4. So here we have shift, means action what we have to perform. The action is shift S3, shift S4. And for small for A, for capital A, we have moved from I0 to capital A, we have moved from I0 to I2. So there is a action, or we have just write the go to, means from which state to which state, that is 2. And for 1, for S we have go to 1 state. So now from state I0, from state I1, that is the except state. So what we have to write? We have to write except state in the dollar column. So this column, this parsing table is constructed in the same way. We can construct it in the same way. I have just told you how we are constructing the for the item I0. We can construct it for the respective states also. So this is the table. Now once we make, so this is which table is this? This is the table for LALR Parser. Now we have to construct or convert this table to the LALR Parser. How we can construct? Here we can see item I3 and I6 are similar except their look ahead. Item I3, this one, S6, I3 and I6 are same. They are same. So only their look aheads are different. You can see here I1, I3 and I6. They both are same. Only their look ahead is different. This has dollar, this has A/B. So we can, what we can do, we can make or combine those two columns, so 3 and 6. In the same way, item I4 and item I7 have similar, except their look ahead, only their look ahead is different, as they are same. In the same way, I8 and I9 are similar, only their look aheads are different. So what we can do, we can combine those states, means I3 and I6 we have combined and make another state I36, and I4 and I7 are same, we can combine this. I8 and I9 we can combine this. So this is the table. What we have done, we have replaced all the states that contains 3 and 6, we have replaced those states with S36. The states that contain 4 or 7, we have placed there 4, 7, S47, you can see here S36, S47, S36. So in the same way, we have reduced the table. So this is the LALR parsing table. Now we have to remove the unwanted rows. As we can see, 36 has the same data twice, so we can delete one row. So in this we can see here this S36 and S36, S47, S47, 89, 89. So these are these two have the same entries, so we can delete any one from these. In the same way, this I4 and I7 have the same entries, so we can delete that also. So the LALR table look like this. We have reduced all the entries or all the repetitive entries. Thank you so much.